the screen, right? It's not, you don't see me, but you might hear your voice because the Bluetooth is picking up my voice anyway. So now we're talking about graphing what they're calling a function rule. And, to you, what does the function rule look like here? Oh, still not. There we go. I mean, it looks like an equation. So if you're given an equation, which we're calling a function rule, and you had to graph, then the first method you might use is just plot some points. Make a table of values and plot some points. So here's a table of values. Now, where did they come up with those values for x? Yeah. Where do you come up with the input values when you're making a table of values? You make them up. You get to choose, right? Whatever it is, you get to choose. So this is the input you choose. I mean, they chose these 4 points, but you could have chosen different points. You're still going to get the right graph. So now we got to come up with the y values. We know that for every x value, there's a y coordinate. How do you figure them out? You plug in the x values one at a time. And they've actually done the math right here for every one. Right? So if you plug in -1, you get -2 times -1, which is 2, plus 1 is 3. So plot the point -1, 3. -1, 3. All right, do the same thing for 0, 1, and 2. Here's the points. 0, 1, 1, -1, 2, -3. 1, 2, 3. Okay, now, can we connect those dots? And the answer is yes, because we expect that this x is a real number. It could have any value at all. It could have a decimal value. It could be an irrational number. It could be anything. So there would be a value in between the points that we chose to graph. So when you're given a function like that, that's a continuous line. So definitely connect it up with a continuous line. Now, this section by itself is about function rules, not necessarily linear, but would you say that that's linear? The graph looks like a straight line, so it's linear. Okay. So let's try to do the same thing for this one. Graph this function rule. So what do I need to do to graph the function rule at this point? Make a table of values. Right? Make a table of values, x and y. Okay, what values should I use for 2, 4, 6, 8? Why do you say 2, 4, 6, and 8? Yeah, I mean, he's choosing even numbers because it's being multiplied. X is being multiplied by half. It's going to make the calculations easier. I mean, could he have chosen 1? Sure, you could do it, but then you'd have 1/2 minus 1. Now you got to add fractions. So that's why when you get to choose, you could choose smartly too. Don't choose the hardest thing to calculate. Choose the easiest thing to calculate. In fact, most of the time, you started with 2, but what's the easiest number to plug in there? How about 0, right? How about 0? And 0, I'll say 0, 2, and 4 to pick 2. Now, the truth is, because all of you people have had Algebra 1 before. Some of you were in Algebra 2. And you should recognize that this is a straight line. I mean, it's y equals mx plus b. So truthfully, how many points do you need to graph this line? No. Specifically, how many points does it take to graph a straight line? 2. Right? Right? This is, it takes, I mean, with 1 point, how many lines could you draw that go through 1 point? Infinite, right? Choom, choom, choom. Okay, what if I draw a second point? How many lines could I draw that would connect those 2 points? Just 1. So it only takes 2 points to connect the line, right? This goes back to Euclid's postulates, right, of geometry. It takes any 2 points to find 1 line, and that's it. So now we made 3 because, technically we haven't got to that point where we know y equals mx plus b, but we really only needed 2. But let's do these three. Let's plug in 0. What is the value of y? If you plug in x equals 0, what is y? -1, right? 1/2 times 0 minus 1 is -1. Plug in 2. What do you get?
0.
Right? 1/2 times 2 is 1. 1 minus 1 is 0. Okay, plug in 4. What do you get? 4 times 1/2 is 2. 2 minus 1 is 1. So you're going to graph those 3 points. Okay, I should have drawn it down here more. -1, 0, 1. 0, 1, 2, 3, 4. So the first point was 0, -1. The next point was 2, 0. And the next point was 4, 1. Okay, and definitely because it is a function, and these are real numbers, that's a continuous straight line. You do connect it up, right? Okay. Now you got to get to the point where you don't just look at this thing because of all the words and say, I'm not doing it. Okay, because in the end, it's no harder than the problem we just did. It's wrapped with some words around it, but in the end, it's asking you to do kind of similar things. The function rule W equals 8g plus 700 represents the total weight, W, in pounds of a spa that contains G gallons of water, right? So there are two variables, W and G. All right, what would be a reasonable graph of the function rule given that the capacity of the spa is 250 gallons, right? So let's say if I'm going to make my table of values, right? What is the input variable? Is W or G the input? G is the input. W is the output. You would say that W is a function of G, right? So we're going to put the G here and the W here. What kind of values? I mean, we get to pick the values for G. What kind of values would we pick given the physical nature? Can I pick negative numbers? Would it make sense to have negative gallons in a spa? What's the smallest number you could plug in there? 0, right? It could be empty. It could be empty. And based on what they said in the problem, that the spa is only 250 gallons. So what's the biggest number? 250, right? And, if you're going to plot any points in between that, it's up to you to pick them. But it wouldn't make any sense to pick a number bigger than 250. And you can't go less than 0, right? The number of gallons is not a negative number. Do we want to pick any other numbers there? Do we recognize that being linear? Does it look like mx plus b? Yeah. It definitely is. Okay. So we don't really need more than 2 points, but I'll pick another point just for fun. How about I pick 100? So what do you get? What would be the W if you plugged in 0 for G? 700. And what does that represent in terms of the spa? It's empty. So what is the weight of this thing? The second question. What was the weight of the spa when the tub was empty? 700. So the thing itself weighed 700 before you start putting water in. Okay, what's going to be the value of W when you put in 100 gallons of water? 1,500. Okay. And what is going to be the value when you plug in 250? What's 8 times 250? Right. That's why we do all this multiplication stuff. 0, 40, 20, 2,000. So it's 8 times 250 plus 700 is 2,000 plus 700, 2,700. Okay, so if I was going to graph that, are these evenly spaced numbers? No. I mean, if it's 0 to 100 and was evenly spaced, the next going to be 200 and it's 250. So you might want to be careful as you do this. Like I'm going to make my tick marks every 50. Right, and that'll make them evenly spaced. 3, 4, 5. Here's 100. Here's 250. And then this looks like we should have our y-axis or w-axis that goes up. It's got to go up to 2,700. just to make things nice and even, I'm going to make it 3,000. Okay, so 1, 2, 3. There's 3,000. And I'll make tick marks in between for the 500s. Right, there's 1,000. There's 2,000. Right, plot point. 0, 700 is here. 100, 1,500 would be here. And 250, 2,700. Maybe about there. I'm just estimating. Okay, and then can I connect those up with a line? Absolutely, right? Because you started filling here, and that just kept getting more and more and more. So there were values in between, and it actually shouldn't have done that because they said it only has 250. So stop. Okay. Now, when you're given, this is coming from two different sections. That was section 4.4. This is section 4.6. If you're given a set of points, the set of x values for that point is called the domain. It's really, as we've seen, that's the input values of what the domain is. And in this set of points, you can see it's -2, 0, 4, and 5. That's what that right there is the domain. And you notice the curly brackets they're using to put them in? Those are called set brackets. It's the set of x values. Right? The range are the output values. It is the set of the y values. 0.5, 2.5, 6.5, and then there was another 2.5, but notice that they don't repeat a number. If it's already in the range, you don't need to do that. Now, when you make a mapping diagram, which takes every value in the domain to every value in the range, you're going to draw arrows that connect the x value to the y value. So you can see the -2 is connecting to 0.5, 0 is connecting to 2.5, 4 is connecting to 6.5, and 5 is connecting to 2.5, which already there was one number that did that, right? So which means there's two arrows going to the same number in the range. Is that a function? Yes. It's okay to have more than one arrow going to the same member of the range, right? What has to be true is there could only be one y value for each x value, okay? So this would be a function. Right, this is a function. Okay. Now, if we look at this set of points, the domain are the x values, 6, 4, 6, 5. So they've written them in order, no repeats, 4, 5, 6. The range is the set of y values, 5, 3, 4, 8, and they've written them in order, 3, 4, 5, 8. Right, here's the mapping diagram. 4, 5, 6 is mapping to 3, 4, 5, 8 because 6 mapped to 5 and 6 also mapped to 4. You got two arrows coming from the same member of the domain. Is that function? No. That's when it's not a function. Right? Not a function. So I know you've had domain and range before, and it's not much more to it than you've heard of it before. Right? If you have a set of points, of fixed points, you could just look at them and tell whether it's a function or not. Just looking at this one here, is this a function, the A? Look at the set of points and tell me whether it's a function. Let's see, look at the x values. 4.2 and 5 and 7 and 4.2. Is it a function? Right? Not a function. Okay, how about this one? -1, -2, 4, and 7. Is it a function? That is a function, right? Right. No repeats. Therefore, function. Okay. Now, if you have a set of points like this one here, I mean, honestly, did we need to make a graph out of this to tell whether it was a function? No, you could have told right here, -4 and -4, not a function. If you look at the graph, graphs have another test for a function, which is called vertical line test. Right? If you could draw a vertical line and intersect more than one point, it's not a function. So this -4, x equals -4, has that point and that point And so from a vertical line test perspective, you say not a function. Okay, if you're dealing with a function rule like y equals negative x squared plus 3, then how many points are there on this function rule? How many values of x could you plug in to that function rule? Infinitely many, right? There's no way to write down every ordered pair which makes up that graph. Therefore, you can't just make it that and look at the x values. So instead, you're going to have to graph it and then see whether it passes a vertical line test. I mean, this is a parabola that opens down. Can you imagine anywhere on that graph that a vertical line would have crossed in more than one spot? No. So that's a function. That's how you tell whether a graph represents a function, right? So this is a function, and this is not. Okay. And now the function notation is when you use the f of x. Okay. And again, it's the same thing as writing negative 3x plus 1 is to say f of x equals negative 3x plus 1. Right? Y equals f of x. Now, you don't want to look at that and think like f is a variable, right? It's not a variable, and it's not a multiplication that is going on in between the f and the parentheses x, right? It is the math notation is to say f of x. And then if I want to find the value of, over here, let's say I was going to do my function rule or graph it, making a table of values. Let's say I wanted to plug in x equals 0 here to find the value of y. Using function notation, you would say f of 0. Right? And how do you evaluate f of 0? Well, since you put a 0 in the place of x here, you put a 0 in the place of x here. That was wrong. And calculate. How will you find f of 1? You plug in negative 3 times 1 plus 1. Negative 3 plus 1, negative 2. So function notation, f of x. And you can use other letters. I mean, f of x is always the one used because it's f. Function starts with f, right? But we can see, they say it could be g, could be h, but it could be anything, right? Any letter you want can represent the function. A lot of times, even if you got y equals negative 3x plus 1, you would say y of x equals negative 3x plus 1. Just to emphasize the point that y is a function of x. You input x, you output y, right? It is a function of that. Okay, so given this function rule, w of x equals 250x represents the number of words, w for words, you can read in x minutes. How many words can you read in 8 minutes? How would you figure out how many words you could read in 8 minutes if this is the function? So you would say w of 8 equals 250 times 8, right? So you just plug in. If you want to know how many you could read in 8 minutes, plug in x equals 8. And that is 2,000. That's exactly the problem we did with the other one for the multiplication. How many could you read in 6 minutes? Plug in 6, right? That's how you use function notation. W of 6 equals 250 times 6. Who knows that? Correct. 1,500. Okay, so that is the lesson for today, right? The first few were graphing, make a table of values, do some graphs. The next few are domain, range, function notation.